Hi everyone, Jake Howard here, and in this video we're going to talk about electronic speed controllers and what they do for your drone. The abbreviation ESC is a term you will hear often in the FPV community. ESC stands for Electronic Speed Controller. This vital drone component takes power from your battery and a signal from your flight controller and translates that into the rotational motion of your motor. In this video we will discuss the differences between ESCs and how to select one for your drone. Every drone contains one ESC system for each motor used. Without an ESC, motors would only be able to turn on or off, and changing speed of their rotation would be impossible. Because drones rely on constantly changing motor speeds, an ESC is required to convert the battery power and flight controller signal into motor movement. The inputs to an ESC are battery voltage and motor signal. In the case of brushed motors, which are used in very small drones, the ESC output is simply a voltage that is either increased or decreased to change motor speed. However, in the case of brushless motors, which are more commonly used in drones, the ESC output is pulses of current, the timing of which changes the speed of the motor. In this way, an ESC converts the direct current from your battery to alternating current, which drives the electromagnets in the stator of your motor, changing the rotational speed of the bell and prop. Make sure to watch our motor video to understand how they both work together. 4-in-1 versus individual ECs. When selecting an ESC for your drone, there are a few things to consider. For drones, you will need to decide between a 4-in-1 ESC or 4 individual ESCs. A 4-in-1 ESC looks something like this and is usually placed on the stack with the flight controller. In a 4-in-1 ESC, you will see the 4 sets of 3 solder pads for the brushless motor connections, 2 pads for power and ground from your battery, and usually a connector for the wiring harness to the flight controller. In the wiring harness, there will always be the signal wires for each motor, and usually also power and ground to power your flight controller. The other option you will see when selecting an ESC system is individual ESCs. These look like this and are usually mounted on the arms of the drone between the motor and the stack. Individual ESCs will have the same 3 solder pads for each motor wire, a signal wire to be soldered to the flight controller, and a power to ground wire for battery power to the ESC. As far as functionality is concerned, choosing between a 4-in-1 ESC or individual ESCs will have no effect on the performance of your drone. However, there are still other benefits and drawbacks to each system. One consideration is the physical layout of your drone. Some drone frames do not provide ample space inside the stack for a 4-in-1 ESC and everything else you would need. In this case, individual ESCs help save space in the frame. Another argument for individual ESCs is that if the ESC fails, you only have to replace the one that failed, rather than the whole 4-in-1 ESC, which is more expensive. However, 4-in-1 ESCs are better protected inside the stack than individual ESCs out on the arms, and sometimes individual ESCs will get damaged from props or other collisions. Processing power. Most ESCs on the market are controlled by onboard microprocessors, running firmware called BL Heli. Some ESCs use 8-bit processors and run BL Heli S, and a lot of newer ESCs use 32-bit processors. The bit rating of the processor essentially tells you how quickly the ESC can communicate with digital protocols, such as D-SHOT 1200. 32-bit ESCs are capable of reporting telemetry data back to the flight controller, such as motor RPM, amp draw, and temperature. Although these features are nice, the main functionality is essentially the same between these, and 8-bit ESCs tend to be slightly cheaper. Voltage, and amp rating. ESCs are also rated based on how much current they can pass to the motors. Because the job of the ESC is to switch on power to the motor coils at incredibly fast rates, ESCs can burn out if they are not rated to handle the load put on them. This switching is controlled by a microprocessor and carried out by transistors called MOSFETs, which stands for metal oxide semiconductor field effect transistors, but they are more commonly referred to as FETs. The size and quality of these FETs determine how much current can pass through the ESC. ESCs will have ratings such as 30 amps or 25 amps, and these numbers generally represent the sustained current the ESC can handle. For short periods of time, generally less than 10 seconds, ESCs can handle slightly more current. It is common to see an ESC labeled as capable of handling 30 amps with a 40 amp burst. The amp rating is an important consideration when purchasing an ESC. It is far better to get an ESC capable of more current at the cost of size or expense versus an ESC that might be damaged by a larger current. Larger motors tend to draw more current, and propeller size and pitch draw more current as they increase. For a drone build using 4-cell batteries, a 30 amp ESC will suffice for most pilots. As with other components on a drone, ESCs are rated for how much input voltage they can handle. It is essential to verify that your ESC can handle the full voltage of the battery you will be using. A burnt ESC will cause a crash in every single instance. Capacitors. In the past, ESCs typically came with included electrolytic capacitors. As mini-quads became more popular and in an attempt to save size and weight, these capacitors were removed. As the limits around flight controllers, ESCs, and motors were pushed, it became really clear that the lack of a capacitor could negatively impact performance. A capacitor functions by storing electrons temporarily and can work as a buffer between the battery and electronic components. Quick changes in motor speeds can cause voltage spikes, which can harm electronics and interfere with the video signal. Adding a low equivalent series resistance, or ESR, electrolytic capacitor to the battery lead going to your drone can help to absorb some of the electrical noise and prevent poor FPV video, as well as potentially save components from fraying. ESCs are an essential part of your drone and work hard to control the raw power coming from your battery. Selecting an appropriate ESC is vital to a well-performing drone. Make sure you consider your motors, propeller size, battery, and end goal for your drone as you select an ESC. This is a component that requires some trial and error to really understand fully, so don't hesitate to ask any questions and have fun flying.